In this video, we're going to use the discriminant to determine how many solutions a quadratic equation has and what type of numbers the solutions are. Before we get to the actual discriminant, let's look at some background information. Let's take a moment to analyze the relationship between a quadratic equation, the x-intercepts of that quadratic equation, and the solutions. So here I have the graph of this quadratic equation, and we notice that it has an x-intercept at -1 and an x-intercept at 3. Now if we set that same quadratic expression equal to 0 instead of equal to y, so now what I've done is replace the y with a 0, we notice the solutions to this equation are the same as these x-intercepts. And that makes sense because when y is 0, the graph is at the x-axis. So the x-intercepts of a parabola also show us the solutions when that quadratic expression equals 0. Well, a parabola actually does not have to cross the x-axis, does it? So when we have a parabola that crosses the x-axis twice, well, then we know it has two real solutions. A parabola can have its vertex right on the x-axis. So in that situation, there's only one real solution. Or a parabola could never hit the x-axis. In that case, there are 0 real solutions. Now, by real solutions, I mean solutions that are real numbers, like the square root of 17 or the number 8. Those are real numbers. I'm going to take a moment to solve 3 different quadratic equations with the quadratic formula. Now, I'm not going to go through the details of the quadratic formula here, so if you have questions about that, you can watch a different video. But we are going to focus on and highlight one part of the quadratic formula. So first, I'm going to solve the equation 5x squared plus 5x plus 1 equals 0. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that over 2a. Now we simplify underneath the square root sign and continue simplifying underneath the square root sign. And we get our solution. Now I'd like to focus on this part of the solution here. The square root of 5 is a real number. And so if we think about how many and what type of solutions we have here, we have 2 solutions that are real numbers. So we'll say 2 real solutions. Right, here's another one. So let's solve that one for x. X equals negative b plus or minus the square root of b squared minus 4 times a times c. We understand that there's a 1 in front of the x squared, so that's our a. All that over 2 times a. Let's continue simplifying underneath the square root sign. Square root is 4. 4 times 1 is 4, so we have 4 minus 4. Well, 4 minus 4 is 0. And the square root of 0 is 0. So that just kind of goes away, leaving us with negative 2 over 2. We can think of this fraction like a division problem now. And we see that x equals negative 1, because negative 2 divided by 2 equals negative 1. So notice here, instead of having 2 real solutions, we have 1. Now, back to this one for a moment. Remember, this means negative 5 plus the square root of 5 over 10, and negative 5 minus the square root of 5 over 10. That's why there's 2 real solutions. But here we have 1 real solution. Now, the reason why we only have one real solution was because we ended up with 0 there, wasn't it? And that square root, this plus or minus part of the equation went away. All right, one more quadratic formula. In this case, n equals, let's see, b is 1. So negative b plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Continue simplifying. 1 squared is 1. And 4 times 3 is 36. And 1 minus 36, that equals negative 35. So here we have a negative number underneath the square root. Fortunately for us, we can use imaginary numbers to continue and get solutions. So that would be n equals negative 1 plus or minus the imaginary number I times the square root of positive 35, all of that over 6. I equals the square root of negative 1. So the square root of negative 35 just equals the square root of negative 1, or I, times the square root of 35. So here's our solution. And we have two solutions once again, negative 1 plus I times the square root of 35 over 6, and negative 1 minus I times the square root of 35 over 6. But those are not real numbers. Those are imaginary numbers. So we have two imaginary solutions. Now, on each of these, the number of solutions and the type of solution was determined by this expression underneath the square root sign. So that's where we're headed here. And that number underneath the square root sign was determined by this b squared minus 4 times a times c. Well, that expression is so important, it has its own name. The discriminant. The expression in the quadratic formula that is inside the square root sign, so that's b squared minus 4 times a times c, that's called the discriminant. And it tells us that if b squared minus 4ac is greater than 0, then there are two real solutions. B squared minus 4ac equals 0, then there is one real solution. And if b squared minus 4ac is less than 0, so a negative number underneath the square root sign, then we have two imaginary solutions. Another way to say this here is we have two non-real solutions. Now remember, one important thing this information tells us is how often the parabola crosses the x-axis. So if we have two real solutions, remember that means the parabola crosses the x-axis twice. If we have one real solution, that means the vertex of the parabola is right on the x-axis. And if we have two imaginary solutions, well, that means the parabola never crosses the x-axis. Let's give it a try. For each of these examples, we're going to find the discriminant and then state the number and type of solution. So we're not actually solving these. We're just using the discriminant to learn some information about the nature of this equation. All right, so here we have a equals 2, b equals 3, and c equals negative 5. The discriminant is b squared minus 4ac. So that would be 3 squared minus 4 times 2 times negative 5. Or 9, let's see, negative times negative is plus. I'm going to put that there. So if negative 4 times 2 is negative 8, and negative 8 times negative 5 is 40. All right, so for b squared minus 4ac, the discriminant, we get positive 49. I'll even emphasize that by putting a positive sign there. Now that's not the solution to this equation. It's just the discriminant. And all it tells us is that we have two real solutions. because the discriminant is positive. So if we were to solve that equation, both solutions would be real numbers. Once again, we'll find the discriminant. So here we can see a, b, and c. So we have b squared minus 4 times a times c. Go ahead and simplify that. See here we have negative times negative times negative. That'll be negative, so I'm going to put that here right now. And negative 4 times negative 3 is positive 12. And 12 times negative 5 is negative 60. So we'll have 36 minus 60. And if we calculate that, we get negative 24. So the discriminant is negative. That tells us that we have two imaginary solutions to this equation up here. Once again, it does not tell us what the solution to this equation is. It just tells us what type of solution we get. You have to be careful that with our quadratic equations, before we find the discriminant, we need to make sure it equals 0. So this one does not equal 0 yet. Let's go ahead and fix that. Now our quadratic equation equals 0. Let's see, in this one we have an a of negative 1, a b of 2, and a c of negative 1. We're using the discriminant to figure out the number of solutions and what type of solutions they are. So we have b squared minus 4 times a times c. So we have 2 squared is 4, and we have negative times negative times negative. That's going to end up being a negative. And we have negative 4 times negative 1 is positive 4, times negative 1 is negative 4, so it'll be minus 4. Right, and we have 4 minus 4 equals 0. So now this is just the discriminant, not a solution, but what it tells us is that there's only one real solution. So if we were to solve this equation here, there would only be one solution, and it would be a real number. Last one here, we do have this equation equal to 0, but we notice that we're missing something. We're missing the c. Well, that's okay. So here we have the a will be negative 3, the b is negative 2, and the c is 0 because it's not there, so it's plus 0. All right, here's our discriminant, b squared minus 4ac. That's negative 2 to the second power minus 4 times a times c. All right, negative 2 squared, that's positive 4, because negative times negative is positive. Anything times 0 equals 0, so this would be minus 0. Or in other words, the discriminant equals 4. So that's a positive number. So we know that if we were to solve this quadratic equation, it would have two real solutions because the discriminant is positive. Remember, that also tells us that the parabola, or the graph of this equation, would cross the x-axis in two locations. In this lesson, we learned how to use the discriminant to figure out how many solutions we have and what type of solutions they are. Hopefully these examples have been helpful. This is Mr. Ela, signing off.